Welcome to Zero Gravity's podcast. Today we have a great lineup of guests, and we're going to be talking all about AI, trusted execution environments, and a lot of the infrastructure around how we make computing confidential in this blockchain age. Guests that we have, and we'll get intros from each of them. David, I'll start with you. Give us a brief description on yourself, 1 to 2 minutes max. People are very strict on this podcast.
Sure. Yeah, no, appreciate you having me today. Excited to be here. David Attermann. I'm the head of Web3 investments at M31 Capital, focusing on both liquid and illiquid investments across the infrastructure layer, infrastructure middleware, kind of like general purpose technology. Actually, my background is in traditional finance, spent a decade covering networking technology companies in Web2 across investment banking, venture capital, private equity, and was at a hedge fund. So kind of did it all. And it's actually how I got into Bitcoin initially in 2014, actually almost exactly 10 years ago. Saw it as disruptive technology to data networking over kind of anything else, and kind of got interested on what you could build on top and how that could be disruptive to kind of centralized systems that we have today. And so kind of invested, followed along for a while, and then 2020 DeFi summer kind of felt things were real and decided to leave the equity hedge fund world and launched Onchain Capital early 2021, which was a liquid token investment fund, which ultimately merged with M31 end of last year. And I've been with them for a year now, and been great so far.
Wow, so David, we're happy to have you on the panel. And then let's go to Mike.
Hi, yeah, I'm Mike Bursell. I'm a geek at heart, really. No one lets me code anymore, which is probably best for everybody. I've been a security architect. I've been a product manager. I've been a CEO, founder of a startup, co-founded an open source project, all those sorts of things. These days, I'm executive director of the Confidential Computer Consortium, and I'm sure we'll talk about that a bit in the future. But that's part of the Linux Foundation. I head that up, do some other stuff in my spare time as well. But I'm a kind of pure security distributed systems guy. And I love the intersection with the AI and the Web3 stuff. It's just so cool. So looking forward to talking about it.
We're going to be talking about that a lot today. Nukri?
Thank you for having me. My name is Nukri. I have PhD in nuclear physics. Last 15 years, I do projects across decentralization, high-performance computing, and confidentiality. There are a few projects in media distribution, intellectual property management, confidential and secure collaboration based on decentralized data sources, digital marketing. Our clients were huge enterprises like banks, telecommunication companies, retailers, big media companies. And our last project is a super protocol platform for decentralized confidential data collaboration. And we served about 100, in my previous project, Egregion, we served about 150 million users, unique users profiles, and processed about 1 billion transactions daily. We were awarded by Microsoft a few times the country partner of the year. And this paradigm and narrative is genesis of super protocol to make AI and data collaboration simple using our marketplace and confidential cloud. This is what we are developing for Web3 industry.
Absolutely. Well, I'm excited to talk more about that when Nukri comes in with his bio. I feel like I got to work harder. I got to get more PhDs. But let's start off with David, and let's talk about the outlook and demand for trusted trusted execution environments in Web 2, Web 3. So talk to us a little bit about the current trends you're seeing in the intersection of AI and blockchain. Where should investors be focused on? Like, what problems are really worth solving in this like intersection of blockchain and AI?
Yeah. Well, I'll answer that, I guess, in two sections. So kind of as an investor, obviously see, all the deals that are in the market today and obviously what has gotten funded. So I've split it up into kind of two sections. A, kind of using AI for blockchain, and B, kind of using blockchain for AI. And in the first one, there's a lot of focus on kind of abstracting away a lot of the complexities of Web3, using kind of AI agents as the interface for using a lot of these Web3 primitives. Obviously, Web3 is not the easiest thing to use, and so to the extent you could abstract and automate away a lot of the technology, it'll be helpful for people to kind of get onboarded and start using these products. And so AI agents have been a very big focus on kind of like the interface side of things. Less focus has been kind of on the back end side of things, using AI agents as kind of the glue for putting together composable modules, I would say, kind of like connecting compute with data and connecting that with other systems. And so I think that's still earlier days, but I think something very interesting that is in the works. Other kind of categories, co-processing, which is leveraging off-chain compute resources with AI models, and kind of, if you can verify it, you can make it trustless, and then you can integrate it directly with smart contracts. And so, it allows for much higher utility, much more powerful smart contracts. And, we're still early days there, but there's a lot of experimentation going on. Using AI for auditing code, kind of security. There are a lot of ways you could leverage it there, as well as kind of code creation, application creation. This kind of goes with the abstraction point, but kind of automating a lot of the complexities in creating smart contract code kind of accelerates the innovation process. And on the flip side, using blockchain for AI, Nukri will go into a bit more detail, but kind of monetizing your data, your model, or kind of data labeling services, can be done in a decentralized manner, as well as kind of decentralizing training, inference, and data collection, which lowers costs and arguably, theoretically, can compound AI in ways that Web 2 can't. Also kind of proof of humanity and also biometric identification, which will be important in the AI age, as well as kind of like verifying and watermarking data for ingestion into models, so you can kind of audit how models are put together, which is becoming more and more apparent for enterprises who have been sued by many media companies out there for training on their data. And so that I know that's a lot, but that's kind of where the focus is. I think the two kind of areas that I think are the where the focus should be, or kind of the lowest hanging fruit. The internet is kind of evolving from what I would call search-based browsing to more of a large language model / arbor of truth model, where instead of kind of looking something up on Google, you're basically asking a question and getting an answer, and you're not kind of comparing sources. You're kind of taking it as truth. And obviously, if that model is centralized and powerful and has a lot of influence behind it politically, whatever it is, that runs into a lot of issues into what's actually real, what's actually true. And if you're not
luckily, no one would
sources,
ever abuse that, though, so we'll be entirely safe, right? Okay. Yeah.
And so and we saw it with Google Gemini had some issues with their image generation. ChatGPT, I've seen kind of examples of political bias in some of the prompts. And so to the extent that you can provably have a neutral, because nothing's ever neutral, right? We're humans and we bias in everything, but to the extent that you can verify that it is more neutral than others, that'll be really valuable, especially as we take the answers to these LLMs as truth, more and more in the future. So that's one area where blockchain decentralized systems can uniquely enable over centralized systems. And then another interesting area, and this is kind of for AI, but it's really for data networking in general, and that's data security. Centralized systems have a fatal design flaw, and that is a single point of failure. And so anything that can be hacked will be hacked, and we see it all the time. Every major company, if you follow Nukri on social media, he posts about every data breach, and there seems to be like a massive one every week, and people just kind of brush it off and kind of accept it as just a norm. And I guess it's not okay, but people live with it today. But as AI progresses, as we kind of incorporate it more and more into our daily lives, we're going to need to feed it or give it access to more sensitive and personal information, data, access to our assets. Because AI is great and it'll keep accelerating, but in terms of utility and functionality, that only it can only be as valuable as the context that you give it, that you give these models, you give these agents. And so they're going to need access to personal information, to sensitive information. And so the need for actually secure confidential systems becomes more and more apparent. And this is an area that a blockchain orchestrated cloud network like Super Protocol, and I'm sure Nukri will go into that, can uniquely solve over anything that is accessed, orchestrated, and kind of run by a single centralized company, institution, whatever. And so very much needed to kind of keep this sensitive data that we want to interact with AI, provably secure.
Can I jump in on a couple of those things? So I think and tie them together a bit actually. So you talked about things being neutral. I'm not sure we're ever going to be able to prove that things are neutral. But what hopefully we can do is track back the provenance and say, okay, well, this came from these data sets, and we know where they came from, and they are maybe from a particular think tank or from a particular organization or whatever. So being able to track back what we're using to that. And I think the same goes to your last point, where assuming we have assurances about confidentiality and stuff, we also need to be sure that we can track back where that came from and check that this has come from my data and it has only been processed by these parties who I am happy to trust with this data for this amount of time. So bringing all that stuff together, that provenance and that security is, I think, really interesting. And I suspect, given what we're talking about, where we're about to go, because I think without those things, we just don't have a map to get to where we need to go.
Yeah, absolutely. And we're going to be diving into all those topics. One thing we talked a little bit about is about security. So let's talk about high level. David, let's imagine somebody business-wise has never heard of trusted execution environments. Talk to them a little bit about what it is generally, and then what's the business problem it's solving in AI.
Yeah, so I'll go high level and I'll let the experts go deeper later in this conversation. But essentially, it's a secure and confidential enclave, kind of like this area within a GPU or a CPU, which is a computer chip. So it's a physically isolated area that keeps execution and data processing separate from the rest of the device. So even if the operating system or the device is compromised, who's ever compromising can't actually access this enclave within the computer chip. And so, obviously that allows for higher security, but it also keeps code, data, software confidential. And so even if you literally have the device in your hand, you can't abstract that data. And so, it adds a much higher level of security and confidentiality to devices and to compute in general. And a lot of devices have it today. It's in every iPhone. It's in every ledger, so hardware, wallet, and so it's been used broadly today. Hasn't been used too broadly for Web3 systems, but I think you're seeing it more and more being leveraged, and there are a lot of kind of good reasons to include it into these broader systems, given the characteristics that they allow, but also with the confidentiality and the security, but also the ability to remote attest this hardware, and basically you can verify and you can put the verification on chain that the hardware and the software, the firmware, wasn't tampered with, and that the software program was run as it was supposed to. And so, not only do you get confidentiality, but you get a very efficient and practical way to verify compute.
That's you've nailed all the important. But you use the word isolation and you use the word remote attestation, which makes me very, very happy. As this is kind of my field. So thank you. Or you get all the check marks from me.
Wow.
But that plays into exactly what we were talking before. This remote attestation and the confidentiality allows you to take a training model and the data and create an inference model out of that. And know that the answers you're getting out of that inference model came from those original data sets because you got the remote attestation of pulling through, and also to know that as you're doing both the training but also asking those questions, that the questions can be confidential, the answers can be confidential, and the model and data itself are confidential, even if you've got some bad actor who's attacking that system, or you don't trust the sysadmin, or you don't trust the owner of the system, right? And we're in a decentralized world where we don't want to have to trust everybody, right? The whole point is that we can, Web3 is that I don't need to trust Nukri if I'm getting his stuff. I don't even need to know who he is. I need to know that whoever he is, can't mess with the smart contract or what the dApp that I'm running, and that it's going to do the right thing and give me the right answer, and that I can prove that. And that's exactly what TEs and remote attestation provide. So you absolutely nailed it, David. I'm very happy. I'm sure, Nukri, you got stuff to say about that as well, but I thought that was a good description.
And a few words maybe for our listeners. TE looks too complicated. That's why in Super we are developing a ready-made AI data marketplace within confidential cloud based on TE tech. And in just few clicks, you will be able to launch your model, upload your model from our marketplace or from Hugging Face in a fully private, decentralized environment. Just a few clicks, deploy your smart contract. And we wanted this is why we are building Super, to make this road as easy as it possible for a million of projects who are developing billion personal AI agents based on personal data for businesses, private needs, and so on.
Because this is, it's complex technology here, and it needs to be abstracted, and you need to be able to remove the friction. And that's exactly what companies like Super Protocol are doing, and the sort of thing that we're encouraging in the Confidential Computing Consortium as well. So reducing the friction, bringing it to users who don't need to know the really low level detail stuff. And it does get very, very techy very, very quickly if you're not careful.
To say confidential computing is not only about, let's say, regular case of how to prevent leakage from your project of data, private data. First of all, you can guarantee to your customers, to your partners, that this collaboration or business based on their private data will stay always private. It means that you as a developer can provide this security through TE, confidential computing, to your customers. And in simple words, you are owning your Ethereum private key, and no one can reject your crypto from your private key. Absolutely same paradigm works for TE. No one can mesh your data, can cannibalize or compromise your data, and technology guarantees it to all participants. It gives us, yeah.
So I was going to say, and it's not just the confidentiality; it's they can't mess with it either. The integrity is correct. So
Verifiability.
Exactly. So when you're running a smart contract, when you're running a DApp, you know that what's coming out is what should be coming out because the integrity has been checked as well. Again, even if you don't know who is running it or where it's running, because you've got these assurances via the remote attestation, right, Nukri?
Our, let's say, world is based on collaboration between huge companies. The last McKinsey report says 90%, 90, of huge, large and middle companies wanted to collaborate based on data, on their data. But same time, this is, let's say, two opposite vectors. From one side, you need to collaborate with your partners, with your direct competitors, even based on data to observe market, to find insights and so on, but to grow up market. But same time, you need to prevent these leakages and risks of cannibalization of each other. That's why verifiable and confidential computing gives us opportunities to make this collaboration effective, and make this proofable, because you can provide training of your AI model on different devices in a different type of protocols. But same time, you are able to verify this model is trained on this data and meets specified parameters without disclosing of your data of your model. This is a very important narrative. Specifically, it works for decentralized aggregation and working with private data. A lot of devices, you heard Apple is going to or is launching their AI agent on all mobile devices. They will aggregate a lot of private data. What happens further? Who will work out, and for what purposes this data will be used? That's why, yeah. Go.
So can I add a little bit of magic pixie dust to all of this, which is open source? Because you need to know that the software which is guaranteeing all of this stuff has been correctly written, and there's not people trying to exfiltrate your data or do evil stuff with these keys as you go along. So we need to make sure that the fundamental stuff behind this, like on blockchain, is open source. And I know that Super Protocol are committed to the importance of open source, and I'm part of the as I said, I head up the Confidential Computing Consortium, which is part of the Linux Foundation. We're about promoting open source and about promoting confidential computing. And we've got, Intel and ARM and AMD and all those big folks and Microsoft and Facebook and all those centralized people. But we've also got some really interesting smaller startup people, including Super Protocol. And so the open source, without that, you just don't get these, you don't get the scale taking off. That's really important.
Yeah, one thing I want to talk about is from the investor perspective, because you guys mentioned, Apple's adding this in. We've got obviously like the big providers, but is this something that's already baked into the cake? David, talk to us a little bit about like TE from an investor point of view.
Yeah, I mean, it's been around, I would say, commercially and like, to the masses for, I would say 10 years. Please correct me if I'm wrong.
It's a bit less than that. It's been difficult to get hold of. There's been bits and pieces, but yeah.
Started from TPM.
Yeah, so we moved on from TPM, even older than that. So, but it's in all the clouds right now. It's all the major clouds.
Yeah, and so it's kind of still early days, but you're seeing TE functionality in all of the new kind of GPUs, and NVIDIA has made a point of kind of growing out their TE capabilities, and so it's the confidential computing market in general is compared to the rest of the cloud computing market, it's relatively small. I think it's around $5 billion annual revenue, but I was looking at a bunch of kind of market forecasts. It's expected to grow 50% annually for the next 10 years. And so that gives you kind of a $200 billion market, in the near future. And so the demand for it is real, and it's becoming a major industry. Now within Web3, it's been, I would say it's been around for a couple of years. A few protocols have integrated it into their kind of directly onto the blockchain. A lot of protocols are working on it, as a co-processor mechanism for verifying compute. I think, more recently, it's gaining a lot of momentum as the most practical way to verify compute. I think, ZK and FHE kind of get all the press. It's kind of the sexy narrative, and it's very interesting technology. And I actually don't think they're competitors. I think they're all complements. They all do kind of slightly different things, and together they kind of create a more full system. But TEs have kind of been thrown out. There are a lot of misconceptions about the security of them, and they're just not as sexy as cryptographically intense mechanisms like ZK and FHE. But if you look at cost, if you look at latency, it is by far the only practical way to verify, complex computation from off-chain in order to integrate it on-chain. And so, for the next 5 years, TEs have been having gained steam, but will be kind of the basis for all, I believe, all verifiable compute used in Web3. I do think, ZK and FHE will probably get there eventually, but you don't need ZK on every workload. You don't need it in many use cases. And so I think the future is probably multi-prover in that, the basis will be, or the foundation will be TEE. And then, developers can kind of program in, all right, what workload do we want to add ZK on top of? Which one do we want, FHE on top of? And I think it'll, the more you can kind of customize and optimize cost, latency, and security, kind of the better the system is. And so I think, it's kind of been a dirty word because it has trusted in it, and we don't trust in Web3. But I think more and more people are seeing the practicality of it, and actually all of the kind of characteristics that it shares with Web3 in general, such as kind of don't trust, verify, etc. And so, I definitely the past year it's been gaining momentum. Kind of something recently that happened more mainstream with the kind of explosion of all these AI agents, all these AI memes, terminal truth. There's a lot of questions on, is it really autonomous? Is it one guy kind of tweeting it? And, the answer is we don't know. There's no way to prove it. There's no way to know, who's actually sending out the tweet. And so a group of researchers from Nous, Flashbots, and Fala put together, and they published a paper on it last week. But basically, they put together an autonomous agent using TEE, and kind of went through all the steps they had to go through. And it's basically the only way that you can provably establish a fully autonomous agent on Twitter. And so that's like a tangible thing that people get. A lot, the past year I've been talking about the tech, and it's abstract, and it's really hard for people to appreciate if there's no like tangible, relevant example. But I think, the report that came out last week, kind of people are starting to get it more and more from my conversations with other investors. So, hopefully it gets integrated more and more, because I think it's only a positive for security in Web3.
And we talk about integrating it more and more. Let's talk a little bit about the Confidential Computing Consortium, kind of the goals of the organization and how it aims to solve some problems around the development of TE.
Absolutely. So I can very quickly do that. So I said we're part of the Linux Foundation, so we're all about the open source. You don't need to be doing open source to be a member, though. And we've got about 50 members, including sort of research organizations, non-governmental organizations, all those sorts of folks. Worldwide, we got folks in Japan, China, Europe, North America, and we do three things, basically. One, we try and tell people about confidential computing because, as we've discussed, not enough people know about it at the moment. Secondly, we do technical work, and we work with things like standards bodies, working on protocols. We work with the Linux kernel maintainers to get code upstream, all of that sort of stuff. But also, we have 13 different open source projects which have been donated by various companies and organizations, which are under our umbrella. So it gives people a chance to work on those together and do some really interesting work there. So we're a safe space for people who are competitors to work together, talk together. And, the thing about the rising tide floats all boats, right? This is a huge opportunity of market, as David was saying. We're looking at 50% growth year on year projected. So there's enough space for everybody to be making a lot of money and doing some really interesting stuff. And so open source, encouraging everything to happen. And that's what we do. Oh, and you don't need to be a member to come along to our meetings. So obviously we encourage people to be members, but you can just come along. And if you're interested, confidentialcomputing.io, and you'll find information there, or just get in touch with me.
Absolutely. And earlier we talked a little bit about how TE works. Let's summarize it one more time, because if it's the first time hearing the concept, it doesn't always hit the first time. Sure. And then let's go into the modern state of it. So
confidential computing provides a TEE, a trusted execution environment, which basically isolates an application and its data from the rest of the system. It doesn't matter whether you have kernel access, hypervisor access, you're an administrator, whether you've compromised the box, even physically it has protections against people physically messing with it. If you have access to the motherboard, it still doesn't help you look in there and do stuff. And with this remote attestation, which basically provides a cryptographic assurance that things are set up as you expect, you can then start building really interesting stuff. So you get confidentiality, integrity, and this assurance about uniqueness and identity, which allows you to build stuff. And so David's already actually alluded to one of the things which is really moving at the moment, and that is GPUs. These originally started, they've kind of taken off in server-grade CPUs, and people have suddenly realized there's this whole AI thing, right? And it'd be rather nice if we could use confidential computing with AI, which means that people like NVIDIA and I can assure you that other folks are going to be doing this soon, have provided GPU capabilities with TEs. And so that's the thing that's going on. What, in terms of the next set of things, I wouldn't be surprised if we sort of see interconnect with network cards or data storage cards and things like that. They're going to be everywhere. It's going to be, not why should I use a TE, but why wouldn't I use a TE? It just is an obvious thing to do unless you've got really very good reasons not to do it.
Mike,
yeah, please, Nukri.
Go ahead, Mike. I have a question. Please, go.
I was going to say Microsoft, their goal is to see 70-80% of all workloads in Azure using these things pretty soon. Sorry, Nukri, carry on, please.
No problem. Just maybe you have updates from ARM, because ARM is publicly announced that ARM v9 architecture includes confidential computing possibilities too. And ARM is the most popular platform for personal wearable devices for automotive and so on and so on. Can you tell a little bit more about that?
Yeah, so ARM has something called CCA, Confidential Computing Architecture, I think it is, and that is coming out. The silicon's coming out very, very soon. I was in Japan last week. Fujitsu, who have announced their new Monaca chip, will have this capability in it, for instance. So although most of the work at the moment is kind of being pushed on the server world, we're going to be seeing it closer and closer to the edge, and then moving even into smaller devices as we go. And so it's absolutely not just server. And also it's going to become easier for people with just a few machines to do their own thing and to run capabilities and provide resources to the blockchain for Web3, for whatever people need to do. So it's just going to become ubiquitous. That's where we're going.
And talk to us a little bit about usually when people think about ZK, or they think about high level cryptography or very privacy heavy things, they kind of think slow. But talk to us, is this high performant? Are there any like vulnerabilities?
So there's always vulnerabilities in everything. I'm a security guy. There is no perfectly secure anything. What this does is it raises the bar significantly. It stops the processing being the obvious place to do the attack. It stops that being the weakest link, right? So that's what's going on there. What's the other question you started off with?
Some people hear these like heavy cryptography, or they hear heavy privacy, performance.
Yeah, sure. So because it's just doing processing, you can run standard applications, standard programs, standard binaries, standard containers, whatever, inside a trusted execution environment at close to native speed. You may get a few percentage hits on this. And again, if you're doing AI stuff in a CPU, it's going to be slow, as you'd expect. So that's why you want to put some of this stuff in a GPU. And of course, you can make slow applications if you want to, but generally, it's close to native. And certainly not, hundreds, thousands, millions of times slower, which is what you see with some other, technologies. Which is why combining technologies, as David said, FHE, you can't have your entire system running FHE. It doesn't work. Use defense in depth. Use all of these different techniques and provide different capabilities and properties. Make sure you understand those and use them wisely to provide the security that is relevant to your system that you're building and the people who are going to use it, of course.
A minor but very important point that in TE you can run well-known open source solutions developed last many years. And regarding this, let's say, cake of security levels, any application includes not only cryptographical secure mechanisms. It should provide services for end user. And who will develop these let's say layers of applications for using same few novel tags represented on the market? You need to develop it. Who will develop it? Who will verify it? In TE, what's the plus of TE technology? You can download code developed by a Web2 ecosystem in open source mode, and immediately run in container in TE environment with no extra development, with no extra knowledge how this cryptographic works, and so on. Just run and use it and provide the secure, confidential services for your clients.
Good point.
Yeah, that definitely transitions well into, let's talk a little bit about what Super is and talk about the problem it aims to solve.
Regarding Super, it's there is let's say few narratives. First of all, it's a easy and quick start for your startup and application to use confidential computing. With no extra knowledge, because you are oriented to develop AI agent, and you don't need to know nothing about cryptographic and tags of how to provide the security. Just deploy your application in container and run it in Super. This is the first one. Next one, using this narrative, we wanted to incentivize ecosystem to upload models, to upload data sets. First of all, private data sets, because coming from our previous experience, large companies and small and medium companies, they want to collaborate with each other. But this collaboration in 99% works outside of public perimeter. They sign a lot of agreements. They choosing third-party trusted solution who will be trusted, and this is predetermined collaboration. Using Super Protocol, we provide these collaboration possibilities, secure private possibilities for everyone. Just deploy your application, connect your protocol with someone else, and you can create this collaboration. Anytime you can stop this collaboration, anytime you can prevent the leakage of your data, and so on, because everything happens inside of this confidential layer. And governed by smart contracts. It's absolutely impossible to deploy billion and billion personal agents based on manually managed landscape by administrators or owners of these services. And that's why smart contract, which is absolutely verifiable, clear, and open for everyone for research, you can deploy your parameters, usage rules, and restrictions in smart contract, connect it with confidential computing of super protocol, and run your agent for your clients. By the way, you see a lot of projects who are using AI agents first of all, to aggregate super sensitive and personal data, business agents, personals, healthcare, medicine, and so on and so on. How should we trust them? And this additional security of confidential computing behind this, a lot of processes just run and go, I believe will work.
So David said a bit earlier on, Nukri, that in the Web3 world we don't like trusting things, but we have to find some things to trust. And with TEs and open source, that means that we can trust those. You've always had to trust the thing that's actually doing your computing for you. You've always had to trust that hardware, right? This way we can trust that without having to trust all the other pieces, and that, I said, with this sort of magic pixie dust of open source, allows you to have this sort of trustless trust that we've been looking for. More security, less trust, I think, is the story, isn't it? Right? That we've been looking for, and I think that's why this sort of putting these two sets of technologies together is really, really interesting.
Yeah, and I want to talk a little bit about what are the specific benefits of you doing this in the crypto Web3 landscape? Is it the smart contracts? Is it the easy attestation? Is it the decentralization? Nukri, talk to us a little bit about why build this in Web3 land.
Decentralization and governance by smart contracts, because just imagine what happens today. We are developing AI God, right? Centralized AI God who will accumulate a lot of personal data inside. And this, it looks, it nerves me to say truth, because my previous project, my previous experience includes projects to work with super sensitive and private data of hundreds of million users. And you remember Cambridge Analytica scandal, you remember WikiLeaks scandals, and a lot of scandals where large platforms manipulate a mass of users and with zero knowledge about what happens inside. It's so easy to manipulate with a mass of users. It's so easy, just few clicks, few likes, few insights, and that's all. And this is it nerves me. That's why decentralization, fully verifiable, and as said Mike, fully based on open sourced Rails, using non-manual confidentiality based on tag, verifiable tag, can prevent the possible collapse of centralized systems. Because you remember, it was many years ago, just providing few likes in Facebook, you will be able to recognize political orientation of your opponent, and it was a problem. That's why just imagine what can we do using much more personal data based in centralized scenario, and that's why Web3 is a nice chance, maybe major chance for AI industry to make this collaboration secure, confidential, verifiable, and clear for everyone. Self-sovereign, I call it self-sovereign computation. When you when you are owner of your data, your computing resources, like you're owning your home, your car, your business, absolutely same should work for AI.
I actually want to jump in quickly just to clarify, super protocol, and full disclosure, M31, we're investors. It's a general purpose full stack cloud, and it's it's trustless and permissionless and all of that, because it's orchestrated by smart contracts. Kind of the first kind of proof of concept will be this AI marketplace for data, for models, for data labeling services to kind of demonstrate the functionality. But what's really interesting in our diligence, we spoke to a lot of the customers that will be onboarding to the platform, and obviously there's a lot of demand from Web3 projects, because Super is, and I've been in around the decentralized compute space for a very long time. Super is the only full stack trustless platform that offers enterprise grade SLAs and full fault tolerance. So other network or other marketplaces, you kind of get an instance of compute, you're not really verifying it, so you can't really run a website or an application continuously on it. So I just want to make the point that it's general purpose. The first iteration is this marketplace, kind of like putting Hugging Face on top of these Web3 rails and allowing confidential and secure monetization, which is not possible on Hugging Face. But what's really interesting is the amount of call them Web 2, whatever, enterprise or companies that have no idea don't care about crypto, don't care about decentralization, but they understand the unique characteristics that only Super can provide. And I don't know how much detail I can go into, but it's a real problem and it's a real solution, and you don't even have to care about crypto to kind of appreciate this differentiated functionality that is really only possible on Super.
Yeah, and I want to follow up on that real quick, because let's imagine we have some builders in here that may be Web 2 builders, and they're like, I got AWS, I got GCP. Like, why? Talk to them a little bit about why this is actually better than centralized systems, even for the Web 2 developers. Like, why come on Super?
It's very easy. If you're a Web 2 developer and you're providing services based on AWS, which is a great cloud, you should your clients should trust you, because it's non-verifiable ecosystem. No one knows what happens inside your administrator account, right? But okay, we trust Amazon, no problem. But same time, if you wanted to collaborate with someone, you need to, to aggregate data from data provider. Who will trust whom, right? You should ask your data provider, okay, guys, we have super secure enclave, put your data inside. Okay, he can agree, but it doesn't work for multiple connections. Someone should be trusted. In decentralized confidential ecosystem, which is Super is developing, you have fully open source stack. You can deploy your confidential computing in a few clicks on your servers. It doesn't matter where, and you can make this connection verifiable for all participants. That's why this is a big difference. And next is that everything behind of smart contracts in Super is governed only by smart contracts. All services, all computation services, 100% of services are governed only by smart contracts. This is another difference from centralized clouds, which is governed by administrator or owner of service. This is two important, narratives we translate to Web3 world, to Web 2 world. And we wanted to incentivize AI developers in Web 2 who are developing. And by the way, it works. We did a huge research of Web 2 developers, including Hugging Face users and so on. So, do they care about confidentiality of their models, of their services, of their protocols? Is it important to provide verifiability for everyone, for all participants? And 100% it works for everyone. That's why this is very simple, message to Web 2 users. Guys, you want to provide verifiable AI services, AI-based services for your clients? Use confidential computing. Yeah.
Yeah, and I was just going to say, we've known since the internet began that the power and the business growth is about collaboration, right? It's the network effect. And if you're using Web3, it's not just whether these people on this marketplace can work together. It's whether everyone can work together. All the resource providers, all the dApp creators, all the data providers, all the storage providers, all the network providers, you get to choose, and it shouldn't matter because it's all protected and isolated. It's everyone to everyone, not just everyone to a few people. It's just opening that up. And that's, I must admit, in the past, there have been times when I've been about Web3 and total decentralization because I've not been sure how it can work. But I think this is one way it can.
Yeah.
And on top of all that, ideology, the benefits, and there are some people that don't care, but there are a lot of regulations on GDP compliance, HIPAA. There will be a lot more regulations on AI. And, for instance, there's no facial recognition model benchmark because the data is too sensitive to kind of put in one area or one system. So there's literally no benchmark today. And so, beyond all of the, maybe, security and all that stuff, it kind of like, it helps, get all this sensitive information in a way that can work with AI, that that works with regulations and works with the regulations that will come, because I feel like there will be a lot more, and so it's kind of like there's no other way to kind of do it on a centralized rails.
And real quick, because we only have a few more minutes left and I want to be mindful of very hard stops, I want to hear a little bit, because it is the Zero Gravity podcast, of course, talk to us a little bit about the collaboration with Zero G and some of the future plans for Future and the consortium.
Mm-hmm. Zero Gravity is a great project, I believe, with a super experienced team behind. And first of all, it's a modular blockchain, it's a modular protocol. They wanted to develop, let's say, one window for every developer to deploy his project in simple, in a few clicks. And this narrative is very close with Super Protocol. We wanted to collaborate with Zero Gravity, first of all, to involve as much as possible AI, let's say, developers, to use decentralized paradigm, decentralized landscape of different services provided by Zero Gravity, including super services inside of Zero Gravity tools. This is first one. And of course, Zero Gravity is a huge project, and the team is going to involve a lot of scalable, secure applications inside of to use Zero Gravity protocol for their needs. And I can name a lot of things we can do together, like to provide secure oracles. You can provide confidential, verifiable oracles based on simple or AI, let's say, complex or stuff. You can involve. We are going to provide incentivization program for Web2 developers to deploy their services. We wanted to do it together. We wanted to involve, by the way, data is king from my point of view, and any project who has access to valuable data, first of all, private data, AI-oriented data, and needs privacy. And this privacy will be provided by Super Protocol, and I believe it will be valuable for Zero Gravity team. And we wanted to facilitate these narratives through Zero Gravity ecosystem. And our experience, as I said, we work with global enterprises, and not only regular Web3 startuppers we wanted to involve. We wanted to work with global companies too. This is another field of collaboration with Zero Gravity team. They have huge experience in this area, and of course, any enterpriser is asking about security and confidentiality of the collaboration. We can provide this, and we can do this win-win story. This is, I can talk about hours about our possible collaboration, but
that's great. I'm sure we'll have a blog post out about it soon. But real quick, before we wrap up, I want everyone to mention where they can find themselves online. I'll start with you, Nukri. Shout out any social media or any websites.
Everyone welcome on superprotocol.com. We have a marketplace for everyone. We have closed team. You can ping me in Telegram, NUKRIB, and we can talk about your project. We can help you with confidential computing. We are ready to explain everything what we know in this area, and we will be happy to make our collaboration wider.
Absolutely. And David?
Yeah, I'm pretty active on Twitter, at @AtterX_. DMs are open for any kind of early stage projects within the infra space or other researchers and investors looking to collaborate on anything. Always like to increase my network.
Absolutely. Mike?
So confidentialcomputing.io if you want to know more about Confidential Computing Consortium. AliceEveBob.com, a security blog. I post there from time to time. I'm going to be bringing it up. At Trust Author on YouTube for short videos on basic stuff to do with anything cybersecurity. But yeah, LinkedIn, find me. Really happy to speak to people with interesting ideas. It's some of the stuff I enjoy the most. So
absolutely. Well, everyone go connect with the guest, and let's continue building the future of Onchain AI.